The first thing we're going to do is write out the reaction. We have calcium carbonate. It is a solid. It's going to be reacting with hydrogen chloride or hydrochloric acid. This is aqueous, it's a strong acid. Products are going to be, as described, calcium chloride. This will be aqueous based on our solubility rules. We're going to get water. This is a liquid. This is the only liquid we really deal with in first year chemistry. And we're going to get carbon dioxide gas. Balance the reaction. We're going to need to have 2 moles of hydrochloric acid in this reaction. The net equation, everything's going to show up in this equation except for the chlorides. The solid has to show up. Because the hydrogen chloric acid is a strong acid, it will separate into the hydrogens and chlorides separately, and the chlorides cancel out in the reaction because they're going to be aqueous on the product side as well. Make sure when you're doing your net ionic equations you include your charges. State symbols are not required, but I'm including them here just for clarification. Now to the stoichiometry. We're going to have a given of 0.5 grams of calcium carbonate. This is what we're going to start with. We're asked about the volume of the hydrochloric acid. We are going to end our stoichiometry problem with our volume in milliliters. So to start, we're going to write down our 0.5 grams of calcium carbonate. We're going to convert this to moles. To do that, we need to calculate the mass. So I got my handy calculator for masses. Mass is going to go on bottom to cancel out the grams. 1 mole on top, since this mass came from the periodic table. Now we do the mole to mole conversion, which, as you remember, is done in every stoichiometry problem we've ever done and ever will do. So 1 mole of the calcium carbonate is going to require 2 moles of our hydrochloric acid. We now use our molarity as a conversion factor. 0.16 moles of hydrochloric acid. That's going to go on the bottom, and we're going to put 1,000 milliliters on top because 1,000 milliliters is equal to 1 liter of solution. Pull up a calculator. We get 0.5 divided by the molar mass times 2 moles of hydrochloric acid divided by the molarity, the moles from the molarity, times 1,000 milliliters, and we get 62.44. We're going to use our answer as 62.4 so that we can keep our number of significant digits correct.